So this is Tom Van Dam. He's now with WJE, Janney Elstner Associates. Also an organization that I worked for many moons ago. I think there's probably a lot of alumni from WJE that attend ACI conferences.
Yes, and notice it's on your lanyard.
Yeah, exactly. It's these guys right here. So he's going to talk about demonstrating low carbon concrete for tilt-up wall panel construction. So thank you, Tom.
Excellent, and thanks, Dean. And it's really great to see everybody here. I mean, it shows a level of commitment at Wednesday of ACI to have this many people here in the morning, so that's great. And Dean, the activities at NEW, they're really taken off, and it's going to fulfill a really important role. So I can't wait to see hopefully we'll be able to get some of that data from that database. That'd be awesome. So I'm going to talk about a project that we're involved with. Acknowledgements, of course. It was our work with it was funded by Climate Works Foundation and Breakthrough Energy Foundation, and particularly Breakthrough Energy supported a lot of this work, the lab and the field work. It was really a collaborative effort with Amazon Web Services, so they were really the client, but working very closely with Clayco, Concrete Strategies, Inc., Ozinga, and Kenstra Ready Mix, and everybody had to work together to make this happen. And then a fairly large consulting team, which of course we all have our thumbs in the pie there, but Davies Crooks Associates, so that's Don Davies, some of you know Don, Nichols Consulting Engineers, my old company, Sutter Engineering, another familiar name, Concrete Durability Associates, that's Doug Hooten, Al Innes Consulting, I don't need to tell you who that is, and then Janney Elstner. So a lot of players, a lot of folks involved. So. And I'm doing something unusual for me. I always give myself 1 minute per slide. I got 35 slides, so I don't have that much time. So I will go through this, I promise you, fast. But our goal was to demonstrate in a real world application using traditional materials, a slight stretch, or just something a little different, but within current technology, and then a big goal, so 3 different materials. And basically what we did is full scale tilt-up wall panel construction based on AWS design and with the desire to achieve tilt-up in 3 days, because 3 days is critical for them to be able to move their construction along. You can't hit 3 days, not happening. We did, like I said, 3 full-scale mock-ups, wall panels utilizing 3 different concrete mixtures. A lot of laboratory work was done, so we'll talk about Labcrete, and then we're going to talk about construction. These are the mixes in summary, and I have a table coming up that'll flash by that has a lot more information than this. But the bottom line is the number 1 mix, standard mix, type 1L cement. It was coming in at about 209 kilograms per cubic yard, kilograms of CO2 equivalent. That's because it was using St. Genevieve 1L 8 cement, and we were just down the street from the St. Gen plant. So we had a very low carbon cement. With close proximity. Next mix had a 25% slag. That reduced our greenhouse gas numbers by about 19%. And the third mix had very little, if no clinker, 100% alkali activated material. They won't tell us what it is, but I think, you can probably make some assumptions. But that one gave us about a 52% reduction. So we're just about 100 kilograms CO2 equivalent per cubic yard. And I'm not mixing those units on purpose. That's how we talk about it. Kilogram CO2 equivalent per cubic yard as it is. And I see him nodding his head, but that's back to our contracting community, right? We got to give them what they are used to dealing with. There will be a report put out, and this report we hope can be widely distributed. Dean, I don't know if you guys allow posting of reports on low carbon materials, but we'll want to share it with you and anyone else who wants to post it. So there's going to be a public domain report. We just got to make sure it meets AWS requirements. They're being very generous in allowing us to share. The big things to take away here are the cement contents on that number 3 mix that was higher, but also notice the amount of workability enhancing admixture that we used with that 3rd mix. So it did require a bit extra admixture to achieve the workability that we were looking for. We were looking for a pumpable concrete, So we're looking at fairly high 6 to 8 inch slumps. Air contents less than 2%, and then unit weights, temperature were measured. We also measured setting times, heat hydration, bleeding potential, and then hardened concrete properties, including compressive strength, splitting, elastic modulus, drying shrinkage, coefficient thermal expansion, bulk resistivity, and maturity. So a full range of material testing was done. Good to see you, Karthik. You could tell him what we did, because he was the guy helping get it all done. Laboratory test results, this is where we're at. And I want to stress, you can do a lot of things in the laboratory, right? You can work with these materials, they can look great. And these materials actually look pretty good in the laboratory, right? These are the numbers, I'm not going to dwell on them. I think this is kind of a key thing to look at, initial set and final set. And if you look at mix 3, it's set the quickest for initial, but it took the longest to hit final. All right, so that's kind of a key thing. Basically, total heat generated, again, is pretty important when you look at mix 3, right? With the addition of slag, we see a slight decrease as we would expect. Mix 3, it's not getting very hot. And that can help us in some applications. Doesn't necessarily help us on a tilt up that we got to tilt in 3 days, right? So this just shows the bleeding results. The reason you only see 2 lines is mix number 3 is there. I don't have a pointer, so I'm going to trip over this thing here. Where's it at, man? Oh, right here. Awesome. That's great. Someone hit the wrong button. Yeah, but so our mix 3 had no bleed. So we got 9-inch slump with no bleed in the lab. Compressive strengths, very similar. Mix 3 started a little slower in the lab, but ultimately hit a little bit higher. Splitting tensile, hard to differentiate. Modulus of elasticity, a little bit stiffer. All of these things are important, but we so often focus on strength, and strength, as you know, is a parameter of limited importance when working with mixes. It's important, but it's overemphasized because it's easy to measure. Things like bleeding, heat hydration are often much more important. Drying shrinkage, we got less with mix 3. So a good finding there. And we took that out to, we're done now with this, right, Karthik? Are we still testing them? Still testing them. So laboratory test results, this is a very interesting one. So what we do is at 28 days, it was just coming out of the moist room. And then after that, I went into synthetic pore solution and we tested it out to 90 days. And what you see is what we would expect. Here we are with the 1L mix, and we see actually a nice doubling of resistivity with the 25% slag as we would expect. And then it goes off the charts with the mix 3. And I'll talk about this in a moment, but that doesn't necessarily mean what you think it means, as Jason's nodding. This is where test results, when we apply a standard test, it gives us an understanding on a Portland cement system, might not be telling us the story for a non-Portland cement-based system. So be cautioned. All of our test methods, or most, are for Portland-based cement systems. As we move to different systems, we lose the relationship. Basic takeaways, all 3 mixes in the lab were workable. A note that would never show up in any lab report you're going to see is mix 3 was highly thixotropic. That mix would stand up straight, and then you hit it with vibration, it would flow. And the other mixes responded like typical concrete. The load bleed in 3 makes you pause because you're now thinking of plastic shrinkage cracking and the fact that the setting was highly delayed to get final set. And then the heat of hydrations really made it clear that during cold temperature placements, mix 3 could give us some trouble, right? We're not going to get that heat. Did I have another word slide in there? Okay, we had low, I didn't show the CT results, but actually the CT of mix 3 was higher by probably 20% or so. We had lower overall shrinkage in mix 3, and then mix 2, we saw that jump in resistivity, which we would suggest means less permeability. It's going to help us keep chlorides out. The off-the-chart number with mix 3, I would say, is suspect until we could squeeze pore solution out of it, which we're not going to do unless somebody wants to squeeze some pore solution out of a specimen for us. Do we have any specimens we could send to Jason? All right, we'll get you some. Squeeze some pore solution for us, my friend. This shows the test site. So we did this test in St. Louis, Missouri. We were originally scheduled, I think, for October. By the time we did it, it was, I think, the first week of December. This just shows the layout. The slabs are laid out on a concrete slab, ready to go. It shows the temperature at the morning when we were doing casting. It's 28 degrees Fahrenheit on the slab. We have ice. That's what this all is ice sitting there, which was very slippery, I can tell you, as you walk by. And so these guys are basically have heat packs blowing the ice off the formwork and getting ready for casting. We instrumented the heck out of these panels. We had strain gauging to measure strain and tilt and temperature, and the idea was as we tilted and rotated the panels, we'd get the strains, and of course, I think a bunch of our instrumentation cables got torn out, which was most unfortunate. So we didn't really get the strain gauging data that we were hoping to get. We also put a bunch of smart rocks in there for maturity, and so we had maturity curves developed, and so we had it completely metered there. Fresh concrete properties, this is as they were delivered and tested on site. One thing to notice is mix 3 started off cooler. It had a very low water cement ratio, less water, heat was being put in by boiling or heating the water. So we started later in the day with a lower temperature on mix 3. Slumps, these were measured later, so they had lost some slump. That's what the asterisk said, that would have been here. And then basically, this one was coming in, eventually dialed in a pretty high slump. Air content's a little bit high on mix 3 than we wanted, and that reflects in the lower unit weight. Standard construction practices were used. This is a crew that does this work day in, day out. They're an amazingly good crew and very patient people. But it shows the concrete was pumped, the concrete was screeded, the concrete was placed, and then finished. And so we just moved through this. I'm not going to delay. I will say that the whiter color on this is mix 3. So mix 3, because of its constituents, was lighter in color. But all of it pumped, all of it was able to be placed. Mix 3, the first batch was delayed. It came out, and that's what it looked like. So we had to, work with mix 3 a little bit. It was a little bit more difficult, but we did get it placed. And I want you to notice one thing. They're just walking on top of that slab and screeding it, but when they hit it with vibration, it would flow. So the mix 3, you could walk right on it, right, if you didn't have vibration, but if you hit it with vibration, it would flow. And so the crew hated mix 3. I think that's a fair statement. They said, never want to see this one again, but we were able to do it. We also needed to use a little bit more of the confab, I guess they call it, right, or what's the stuff they love to spray in the surface? Confilm. It was standard procedure for them to use that, but they used a bit more on mix 3. This just shows the timing. All of this will be in the report. Basically, you're seeing that very similar numbers, actually, with getting it all finished. And they basically, the finishing process was, a little bit of troweling. It wasn't hard troweling, but just enough to get it nice surface on there. And everything was able to be placed and done. And then the sun is setting, and they put some light blankets on top. And, then it was 20 degrees that night. So that's where we sat. Timing for tilt, as I mentioned, we were looking at the criteria is 2,500 PSI compressive and 500 PSI flex. And the test cylinders and beams were placed on the slab with the blanket over them. And how many of you have done this and that's how they do the cylinders? Come on, be honest. You guys ever see that? They just put them on top, right? Normal. We basically monitored maturity. We targeted for 3 days. Mixes 1 and 2 tilted as planned. Mix 3 laid there a little bit. And we were showing very little strength gain based on the cylinders. This is the results of the testing. We have estimates from maturity as well as what they were measured. And if you look at the ones for mix 3, it's showing like nothing, right? Very low strengths, but the maturity was predicting much higher. And a matter of fact, we feel we probably could have tilted at 5 days, but that was a Saturday, and it wasn't going to get tilted on a Saturday, so we had to wait till the Monday. Flexural strength, you can see the numbers there. Basically, the bottom line is that it was really cold, and we also, where the cylinders were placed to cure for the mix 3, were placed in a very cold exposed part. So those test cylinders never got any heat, and they died. And it didn't happen in the slab. But we were able to tilt all the panels. They all went up, and it was, widely viewed as very successful. So just some quick takeaways. The temperatures were really a difficult test. And as we caucused on this, and we said, okay, do we really need a single mix approved for tilt up for an entire job to use throughout the whole year? Or can we have multiple mixes? Can we have 3 mixes? Different arrows in the quiver, Mix 2 was the favorite, So I think they're going to standard move to 25% slag without any issue. And that showed us a fairly decent reduction from standard practice. Everything about it they liked, and the crew liked it the best. It finished the best. They hated Mix 3, like I said, but I think we could get through some of those issues. Match curing was discussed, and I think it would have been the way to go. So, and those of you familiar, match curing is you basically are monitoring temperature of the slab. You have a box that duplicates the temperature that the concrete is experiencing, and so you actually get an actual representation in your test cylinders. Some could say, well, why not just use maturity? And most people, I think that's great, but most are hesitant to tilt the panel without actually busting the cylinder. That's how it works. The crew is saying, no, we need to know that when we tilt it, we don't trust that. I think if we have summer mixes, winter mixes, and we optimize mixes for temperatures, we know these things, it's going to help us a lot. Because if this was the summer, that mix would have been stellar. And that's where we're at with it. The report's going to be wrapped up, I'm hoping, by I was going to say the end of this week, but Karthik, we got a little bit more work to do. We actually have to scrub some images, because Amazon is sensitive about the geometry of their panels, and they want to make sure none of that appears in the report or the public record. But I will say that working with Amazon, we're now about to do a test labs with Amazon. It's called the hyperscalers is what they go by. It's a consortium of people that do data centers. So it's Amazon, Meta, some of the same names you've seen. Amazon, Meta, Microsoft, and Google are all working together, and we're doing a slab demo next. So we're going to do slab on grade with hard troweling to demonstrate 4 different mixes. So we're going to have normal, couple of steps better, and then again the home run ball. And that's going to get constructed this summer. And then their idea is to share that information, and which is unusual for them. They don't like to share information, but they're committed to sharing information. So I don't know, Dean, how did I do with my 35 slides? And am I all right? Yeah. Good, this is what I wanted. I'm on time for questions, so I can take questions, all right? Excellent. So questions are really good. So please, does anyone have any questions about any element of this work? Oh, come on now. Yes.
Great presentation, super exciting stuff. Was there also cost data that was measured, or estimates of where 1, 2, and 3 are going to sit?
Well, there was not. I could tell you our lab testing cost a bloody fortune, but and the instrumentation. But this product is one that I believe Ozinga already has in the market in the Chicago area, I believe, but it is market ready. So their 1157 is market ready. It is, they do have it in production. It's in there. It's a mix that they're producing. So it is being used. So we could probably get an estimate from Ozinga what their material would cost.
How about like labor cost? Does it feel like because they hated 3, is that going to translate into additional cost?
I would say in this case, and what I want you to remember is, right, one, we had an A-team crew out there, and it was a lot of people. You would have to work on some of those workability things differently and even approach. And this is really important with these materials. We want to do exactly the same thing we're currently doing, right? And yet we're going to swap in a material. And what I'm saying is, I think as we get used to these new materials, we will have to do things a little different. We're going to have to optimize them, and I think we'll get those costs down. But I would say if this was the way it was going to be, it would be more labor intensive to put that down in this application. But for a foundation, there would be really no additional cost as long as you make sure you're hitting it with vibration. Like I said, this stuff flowed beautifully under vibration. But you'd look at it without vibration, it's like, holy, man, we can't move this stuff. Yes?
Tom, I'll quote Google's Vice President of Properties. Quote, "We want it clean, we want it green, we will not pay a nickel more." End quote. So the cost is going to sort itself out. You can't think about that. You have to think, is it operationally feasible, technically feasible? Does it meet current or reimagined code? Question for you, absent 28-degree starting temperature, would you imagine that all of these would meet the contractor's 3-day cycle?
Yes. Yeah, I think there'd be no issue that we would have hit the 3 days, even if it was 50 degrees when we started, you know, or whatever. But the 28, it was not just 28 degrees when we started. That day we had some sun, but it probably only got up to 35, 36, and that night it dropped into the low 20s. So it was pretty brutal, and if they would have applied heat under the blankets. But those were pretty thin blankets. I know.
You apply heat, you're defeating that.
I know. Unless you're using fusion to create the heat. Keep that in mind. Yeah, Jason.
Is there a reason to use PLC as your baseline as opposed to the OPC? Because we're already 10% lower.
We use the 1L because that's that market right now. And those of you who, I think you know this, there are markets where the OPC is no longer available, nor will it ever be. So, and there's plenty of markets that way, and this is one of those markets. And this particular OPC is a Rockstar OPC. I'm not trying to give them, I know this one because I work in that market, and it's great, but it's only an L8. I'll point that out too. Now, they're going to go up to, I think, L10 or N12, but I'm told it's grinding capacity or something stupid like that. Yes?
It's, you talk about this draft EPD, where can we get it?
You can, do we have the EPDs in the report? The draft EPDs in the appendix, Karthik? They'll be in our report. Ozinga is very tuned into this in their market, their Chicago market, and they have the ability to generate EPDs that are approved EPDs. So they're not, I said draft because we didn't ask them to give us a formal EPD, and it was not their facility.
And then the material that you use, like the slag, cement, all that, it's EPD, is that supplier specific?
It would absolutely reflect the supplier specific and transport, right? So, I mean, that's the thing, right? We're talking about slag in our market, and we're seeing more and more of it, and we could fundamentally or philosophically talk about there's only so much slag in the world, and if you put this much more in this project, you're taking away from another. But the bottom line is, I think slag, for one, is a great thing for us to be using, obviously, and use it as a gateway drug towards LC3, right? It'll get us towards calcined clays. And that's the idea, is it'll get us used to using lower clinker content mixes, and then we can make that transition to these other pozzolans as they become more available in our market. So I think Dean said this, but if he didn't, he should have. Things are changing, right? I think, Jason, you mentioned yesterday, you said something like, we've been doing this thing for 170-something years with Portland cement mixes, and all of a sudden, our cheese, if you have read the book, somebody moved our cheese. If you haven't read the book, you should get it. Who moved my cheese? But the cheese got moved, right? You're the mouse looking for the cheese is somewhere else now. So we have to find that cheese. The cheese is there, we just got to find it. We're going to have to work a little bit. We're going to have to be smarter, better educated, and we can do this thing. And we're doing it, and that's the great news. But it's going to take a little bit of adjustment. Oops, I guess I'm being cut off, man.